I am Neil Allison, C. Areta, ME student, and I will be discussing about the pressure sensors, its types, manner of sensing, and display. So let's have a review. So what is a pressure? A pressure is the weight or force produced when something presses or pushes against something else. And sensor, a device that detects and responds to some type of input from the physical environment. So there are many types of sensors like the heat, light, motion, moisture, pressure, and temperature sensors. What are the units of pressure? Pascal, PSI, which also means pound per square inches, bar, torr, and atmosphere. And as you can see in this slide, there are values that are equivalent in those units. From the word itself, pressure sensor, it measures pressure typically of gases and liquids, usually acts as transducer, and it generates a signal as a function of the pressure imposed. There are three types of pressure sensors: gauge pressure, absolute pressure, and differential pressure. The gauge pressure sensor. The image shows the flow of the fluid, and the pressure to be measured is reference to the atmosphere. The absolute pressure sensor. The reference of the absolute pressure is the vacuum, and you can also see the pressure to be measured and the digital pressure gauge. Differential pressure sensor. The differential pressure sensor measures the differential pressure which is equals to F1 minus F2. And this image shows the flow of the fluid. For the manner of sensing, there are two types of manner to sense the pressure. One is mechanical and two electromechanical. For the mechanical, the motion created by the sensing element is read directly by a dial or a pointer. For the electromechanical, it converts the applied pressure to an electric signal. Mechanical sensors. They are also called force collector sensors. Use a force collector to measure strain or deflection due to applied force over an area, which is also called the pressure. There are different types of mechanical sensors like diaphragm, piston, Bourdon tube, or bellows. So in these images, you can see the illustration of the types of the mechanical sensors. Let's now go to electromechanical sensors. One example is the capacitance pressure transducer. They are used in low vacuum research and they can be either an absolute, gauge, or differential pressure transducer. So as you can see in this image, the parts of the capacitive pressure sensors. They have lead wires, capacitor plates, sensing diaphragm, rigid insulation, oil fill, welded seals, and isolating diaphragm. Next is the potentiometric pressure sensor. The device consists of precision potentiometer whose wiper arm is mechanically linked to a Bourdon or bellows element. The movement of the wiper arm across the potentiometer converts the mechanically detected sensor deflection into a resistance measurement. And you can see the illustration in this image. Next is the resonant wire pressure transducer. It has a wire grip by a static member at one end and by the sensing diaphragm at the other. You can see it in the image. An oscillator circuit causes the wire to oscillate at its resonant frequency. Next is the optical pressure transducers. In this sensor, LED is used to measure the pressure. Lastly, the piezoelectric sensors. The deformation results in a flow of electric charge, which lasts for a period of a few seconds. The resulting electric signal can be measured as an indication of the pressure which was applied to the crystal. So there are electrodes, output voltage, and the piezoelectric elements in this sensor. You can see it in this image. Next is the Wheatstone bridge. All of the electromechanical sensors has a Wheatstone bridge. It is a simple circuit that is used to measure the resistance. It can be used for high and low pressure applications, and it is the most common pressure sensor. You can see it in the image that there are diaphragm, strain gauges in this Wheatstone bridge. Display. There are two types of display of the pressure measurement reading, the analog and the digital. Digital versus analog. For the digital, it is precise, accurate reading, and the microprocessor will allow programmable functions. A small increment in pressure change is possible to detect, more resistance to overpressure spikes without sustaining damage. And for the analog, least expensive, more cost-effective if the task is for only general reading. It does not require power or batteries. As a conclusion, it is better to use the digital analog since it gives precise and accurate reading. Examples of the analog and the digital. On the left side, it is the analog type since it uses the arrow to measure the measurement reading. And on the right side, it is the digital, which already gives the accurate value. Another example of the digital and the analog. On the left is the analog, and on the right, it is the digital. For the applications of the pressure sensors in the industries, they can be used in the steam power plant to measure the pressure of the feed water and the steam. For the water treatment system, they can be used to monitor the water flow. For beer manufacturing, they can be used in the distillation process. And for the pumps, they can be used to measure the water pressure at the outlet and the inlet of the pump. And that's the end of the pressure sensors discussion. Hope you learned something. Thank you.